Assalamu alaikum. My name is Mahmouda Firdausi and my ID is 12108053 and my topic today is ensemble learning. So, the principle behind ensemble learning is a collectivity of learner yields greater overall accuracy than individual learner. Ensemble learning aggregates multiple learners to produce more accurate predictions than any single model alone. It rests on the principle that a collective of learners yields greater overall accuracy than individual committee-based learner. The core terminology of ensemble learning are base learner, weak learner, and strong learner. Base learner means the individual model or estimator used within an ensemble algorithm. Weak learner means the models that produces less or equal to 50% accuracy. And strong learner are models that achieve excellent performance, typically equal to or higher than 80% accuracy. So now we come to a problem, the bias variance problem. So first we need to know what bias and variance is. Bias is the difference between predicted and true values, and variance is difference across various realizations. To find the real error of a model, we need these two terms. To find the total error of a model, we need to calculate bias square plus variance plus irreducible error. Irreducible error is an error that we cannot comprehend within a model. If a model has high bias values, it will cause underfitting. And if a model has high variance values, it will cause overfitting. Now, why do we use ensemble learning? First of all, we use ensemble learning to reduce error. Combining diverse models yields a lower overall error rate while retaining individual advantages. Secondly, we use it to reduce overfitting. Diverse under regularized model often outperform single regularized models. Thirdly is dimensionality. Effectively serves as an alternative to dimensionality reduction for higher dimensional data. And robustness improves the robustness of behavioral modeling in complex environments. Then we'll learn the types of ensemble learning, that is bagging, boosting and stacking. First we'll go with bagging. Bagging means when we have a training dataset, we divide into some subsets. Then train each subset as a base model and turn them into weak learner to learn their predictions. When their predictions lands the result, we aggregate the results to find a common result. That will be the natural base result of all. We call this term parallel homogeneous. Parallel homogeneous means it trains multiple base learners independently using modified replicate of the training data. Bootstrap samplings and random forest uses this type of model. Now we'll learn about boosting. Boosting means sequential stage construction. What is sequential stage construction? It means new learners are trained to minimize the errors made by previous models in the sequence. ADA boost and gradient boosting are the examples of this method. In ADA boosting, weights that are misclassified are forced to take priority. And in gradient boosting, the residual errors from the previous model is used to set new targets. Now we'll learn about stacking. Stacking consists of training meta-learner based on outputs of multiple diverse-based learners. A model that learns how to best combine these predictions is called a meta model. And then we generalize the models to diverse model types to help the ensemble generalize across the complex boundaries. And then we learn the final prediction. Now we'll learn about some techniques and how they help in real world. The technique majority voting means the mode of prediction from all base learners, and it is applied in binary classification. The technique weighted voting gives higher weight to certain learners, and its application is in imbalanced performances. The technique averaging means mean of individual learner outputs, and it helps in regression problems. And the technique meta learning is algorithm trained based on base predictions, and it is used in advanced generalization. The real world application of ensemble learning are land cover mapping, fraud detection, and Alzheimer's detection. Land cover detection is used to identify trained via satellite, and malware detection to categorize threats like ransomware. Fraud detection is used in banking and financial decision making to predict distress or business failures. And Alzheimer's detection is used to detect Alzheimer based on MRI datasets, complex research. And that concludes my presentation. Thank you.